Alright, so in this video I'm going to show you how to determine if a compound is a strong, weak, or a non-electrolyte. So first, you have to determine whether that compound is an ionic compound or if it's a molecular compound. So it has to be one of these two. Now just to remind you, an ionic compound is when you have a nonmetal paired with a metal. An example would be NaCl. Here you have the metal, and here you have the nonmetal. In other words, they call the nonmetals anions, and they call the metals cations. Alright, so once you determine whether the compound is molecular or ionic, well, this one is easy. If it's ionic, that means it's automatically a strong electrolyte. Then, when you move on to molecular compounds, those that are nonmetals with nonmetals, for example, PO4, phosphate, that's a nonmetal and that's a nonmetal, therefore it's a molecular compound. So if it's a base, that means it's automatically weak. If it's neither, it's not an acid or a base, then it would be a non-electrolyte. Then if it's an acid, you have to determine whether it's a strong acid or a weak acid. If it's a strong acid, it's a strong electrolyte, and if it's a weak acid, it's a weak electrolyte. Now you might be wondering, how do you determine if it's an acid or if it's a base? So there are 10 strong acids that you should remember. So you have HBr, hydrobromic acid, HCl, hydrochloric acid, HI, hydroiodic acid, and then you have HBrO4, which is perbromic acid. Then you have HBrO3, which is bromic acid. Then you have HClO4, perchloric acid, HClO3, chloric acid. Then you have H2SO4, that is sulfuric acid. Then you have H2SeO4, that's selenic acid. And then all you're left with is HNO3, which is nitric acid. So these are 10 strong acids. So if the molecular compound happens to be one of these 10 strong acids, it's automatically a strong electrolyte. Okay, and then any acid that's not part of these would then obviously be a weak acid. You might be wondering, okay, what's an example of one of those acids that happen to not be part of the strong acid category? For example, you have H3O2, that is acetate, paired with this hydrogen, that's acetic acid. Any acid that's part of the carboxylic acid group, for example, anything, for example, R, let that be a compound paired. Well, carboxylic would look like this. You have a C and then an O, and then here it's paired to anything of part of another compound, and then you have the OH. So this OH indicates it's a carboxylic acid, and if it happens to be any carboxylic acid, obviously it's not one of those 10 strong acids, so therefore it would be a weak acid. And then ultimately that would lead you to determining that it's a weak electrolyte. So for bases, to begin with, strong bases are, obviously they're strong bases, let me put it this way. If you have any group 1A or 2A element that is paired with a hydrogen, an oxygen, a hydroxide, or an amine, okay, this is called amine, okay, then automatically you can recognize that as a strong base. Now, obviously, these strong bases, group 1 or group 2A, those are metals, and a metal with a non-metal, these are non-metals, would result in an ionic compound, which is automatically a strong electrolyte. That's why all strong bases are strong electrolytes. Now, if you have anything else that is paired, anything else other than a group 1A or a group 2A metal paired with one of these, that would be a weak base. For example, you could have, let's say, zinc paired with an oxygen. Or, for example, you could notice something like this, which is not a group 1 or group 2A element paired with one of these four. That would automatically be a weak base, which would be a weak electrolyte. And that sums it up for strong, weak, or non-electrolytes.